Good day, and welcome to CFE Media Virtual Training Week for this session on how predictive technologies are evolving through disciplined data collection, organization, and analyses. We'll be joined by Tate Pearson, Senior Director of Engineering and Technical Support Services at ATS. I'm Kevin Parker, an editor with CFE Media and Technology. Following our presentation, be sure and stay tuned for a live Q&A on Zoom that will begin at 2:45 p.m. Central, 3:45 Eastern Time. Today's presentation can provide continuing education credits. CFE Media has met the standards and requirements of the Registered Continuing Education Program. Credit earned on completion of this program will be reported to RECEP at recep.net. A certificate of completion will be available for each participant to download upon successful completion of a test at the end of the presentation. As such, it does not include content that may be deemed or construed to be an approval or endorsement by RECEP. This virtual class session is designed for technicians, engineers, and managers who want to better understand how predictive maintenance and operations technologies are evolving to achieve the digital enterprise, including the infrastructure, applications, and technology standards involved. The learning objectives include understanding the various means of collecting data in today's enterprises, the exploration of best practices to store and organize data, best practices to analyze data into meaningful value creation, and to discover options for operations directed by data-based knowledge. Here are some tips to help you get the most from today's webcast. The exam will be posted on CFE Media websites with the on-demand version of this webcast. The exam is for one RECEP ASIC Certified Professional Development Hour. Before turning to our presenters, we'd now like to share a brief video. Please launch the video.
Manufacturers face many challenges today. With aging assets and a shortage of technical talent, operational downtime can increase and productivity can fall. That's where Advanced Technology Services comes in. We've been making factories run better for over 3 decades. Our industrial maintenance and MRO asset management solutions deliver a safety-focused, skilled workforce powered by technology-driven platforms and analytics, all to improve asset performance and provide measurable results for our customers. Reliability is at the core of ATS, and we're ready to put it to work for you.
Welcome back. I'd now like to introduce today's speaker, Tate Pearson, Senior Director of Engineering and Technical Support Services, ATS. Tate Pearson is the Senior Director of Engineering and Technical Support Services at ATS. Since joining the company in 2010, Tate has served in several leadership positions to drive consistent operational excellence and growth. He holds a bachelor's degree in engineering from Purdue University, along with an MBA from the University of Iowa, and is a certified safety-trained supervisor. Thanks, Tate, for joining us today. The floor is yours.
Thanks, Kevin. This is Tate Pearson. This is the ATS way, a technology-based approach to drive asset performance. This is our comprehensive maintenance solution, which includes the floor blocks to the right. Leadership and skilled workforce, best-in-class process standards, MRO asset management, and a technology-driven performance and analytics. Here's a problem we can solve. Many manufacturing companies find themselves in a situation where they have not developed a robust reliability strategy necessary to keep their production assets in top working condition. They have fallen into a state of reactive run-to-failure maintenance, and they have to depend on a handful of employees who have been at their plant for years and just know how to fix the machines. And then when those employees are nearing retirement, these companies cannot find the skill sets they need in the available talent pool. What has happened to these companies is they have become a people-dependent operation whose factories depend on a few critical people in order to run. And when those people are not around, they have a tough time. Not only that, but while this legacy knowledge maintenance strategy might be a good fix at things when they do break down, there's often no system for learning from past failures in order to prevent repeat failures of the same kind. In today's session, I wish to share with you strategies to leverage and build that expertise throughout a technology-based solution that collects all the right data needed to learn from past failures to better enable the maintenance team to prepare and avoid future failures. Strategies that analyze that data into knowledge and then leverages that knowledge and expertise across a large distributed team, and in turn, drastically reduce the amount of unplanned downtime. Many plants find themselves in a reactive state, and many have preventative measures in the form of PM routes, but that many times is the majority of their actions. A world-class reliability strategy has as much or more of the effort based in condition-based realm and the reliability realm, seen at the bottom of this chart. By implementing condition-based maintenance rather than calendar or event-based maintenance, data is gathered and analyzed to find trends and predict future potential risks for failures. Then once these trends are studied and analyzed for true root causes, defects and deficiencies are attacked or reduced or eliminated on a continuous improvement cycle. An effective equipment strategy includes all four realms, appropriately proportioned as you see along the bottom of this slide. So how do we do this? First, we need a means to collect data and then organize it in a connected and global view. There are various ways to collect the meaningful data regarding factory reliability, such as past failures, parts used, time and skills needed to perform the repair or preventative maintenance work, etc. This data can be stored various ways as well, through capturing work orders via a computerized maintenance management system, manuals, bill of materials, learning management systems, reliability engineering systems are all great sources for the data you need. The discipline in which this data is collected and stored via a data warehouse is essential in order to leverage it into meaningful metrics and reports the team can learn from. Garbage in truly means garbage out. Consistent, disciplined, and organized analysis enables the ability to have a consolidated performance view to bring to the service the greatest leverage and opportunities for improvement. Then once that consolidated performance can be transformed into knowledge, a connected and coordinated global view is needed to get the knowledge out to those who can benefit from it the most for continuous improvement. One way to collect vast amounts of data from the factory floor is through a computerized maintenance management system. A CMMS is the management of work orders performed through a work execution management process, which I will cover in the future slide. Work orders contain the information to do the work, but are also the record of data to collect from that work, such as the steps to carry out a job, the time it takes to do that job, the parts consumed to do the job, and the safety protocols and training required. The best CMMS system also has the ability to add attachments such as manuals, pictures, or schematics to the work order. A robust CMMS is powerful when it allows the entire team to access and contribute to the information needed to keep assets in top working condition. Here are some of the role-based actions within a great CMMS. Operations create reactive work orders, can add notes and print out work orders. Maintenance planners create the plans to execute the work, schedule the work, and collect and learn from data gathered during the work. Maintenance supervisors assign the tasks to technicians and review once completed. Maintenance technicians create work orders, update tasks and work order information, such as what parts they used or time to complete the work order. They can also filter quickly for the tasks assigned to them. Everyone has access to the data and can view, filter, and sort lists in several ways, as well as other functions such as utilizing predefined filters or exporting data to other systems or spreadsheets. Now, all this information and data is no good unless you can harness that power and use it to drive reliability. One way to do that is through Power BI or other analytics to convert all of that raw data into asset level scalable key metrics with automated charts and dashboards. Here's an example. Furthermore, mobility is a key feature to enable the work orders and charts to be accessed on the factory floor via a mobile device. I mentioned earlier that the CMMS houses data fed by a robust work execution management process. This process is the backbone of how the maintenance team gets their work done in an efficient and standardized way, while capturing learnings and improvements constantly along the way. Here's an example which involves 8 main steps shown here. First, a work request is entered and validated for approval. A determination is made as to the urgency of that work. The work is planned with robust instructions, including steps to perform the work, as well as the parts and tools needed. This robust planning ensures the work is carried out efficiently and effectively. The work is scheduled in weekly chunks for the next several weeks, always planning ahead. The work is then scheduled daily by the supervisor or shift lead. And then eventually, step number 6, the work is performed. It's noteworthy to note how much forethought goes into the previous 5 steps, even before a wrench is turned. This ensures quality of work and efficiency. The work is completed and data and lessons learned or opportunities for improvement are captured. And then finally, a management of change step is put in place to ensure robust implementation of any changes required to perform the same or similar work next time is even better. Therefore, the CMMS is an excellent source of vast amounts of data in the way that we collect that data from which we can learn. It is critical to have a robust work execution management process in order to feed good quality data into the CMMS. But then the process needs to be able to learn from that data. For that, analytics can be empowered via Power BI or other analytics tools to create powerful tools and charts in order to learn and improve. A CMMS is just one example of the data source that we can draw from to drive reliability. Other sources are sensors, connected assets, supply chain data, skill sets of employees, and other things that we can collect from our various systems. So now that we have a vast amounts of data that we collect every day, what do we do with it? One method is to think of it this way. Gathering data, as we said, is the first step in a very disciplined, consistent, relevant, and factual way, such that we can learn from the trends in that data in order to drive insights. When that data is analyzed, prioritized to drive really sound decisions. Those decisions and actions in turn drive results in the form of efficient use of materials and labor, predictable functioning of the assets, and in turn driving plant performance. One example of how to drive insights from data is a tool we use to measure success within the work execution management process called the Red-Green Report. Here's an example of what it looks like. The Red-Green Report is a learning tool that helps the team visualize how they are doing for key work execution management metrics, such as crew capacity utilization, schedule success, headwinds that got in their way in order to plan more efficiently. This is just one example of how analytics of the data assist in driving insights and results. A key component in the insights part of this process is to have a centralized reliability function, essentially an owner of the data and analysis of that data to drive results. It's where all the magic happens, and it's where we can leverage that learning across a wide enterprise. By collecting information through various systems and storing in an organized way in the data warehouse on the left, we are able to leverage that data such that things like parts usage, work order history, and predictive technologies are feeding into the system. Utilizing a centralized reliability function and processes, we are able to drive labor efficiency and asset reliability seen in the top and bottom of this graphic. Those are the two main outputs of this function. These centralized reliability processes enable efficient access to technical expertise, advanced analytics for quick and solid decisions, and retention of what is learned into an enterprise knowledge that can be leveraged across the organization. So what are some examples of those main core processes within a centralized reliability function? Here are 5 examples. An easy method to engage a robust and supported help chain, a means by which the maintenance team can raise their hand for help. A clearly defined expert network by skill sets or experience on asset types. Subject matter experts are identified by technical skills assessments and work order history on specific asset types, usually fed by your CMMS. A library of knowledge and a means to share that knowledge across the organization. Things like training videos, best PM practices, troubleshooting guides, finished root cause analyses, continuous improvement examples, etc. How do you store that knowledge and how do you make it easy for everyone to access that knowledge? A work execution management process, which we covered earlier. And finally, special projects as needed for Tiger teams or other Kaizen teams to assemble and dive into tough problems with all the right data, skills, tools, libraries that this centralized function affords. So how does this all come together and what is a good case study example? Here's one. An aerospace manufacturer had a CNC machine that was down often and running poorly when it was up. The asset had currently been down for weeks, and the plant manager was desperate for a robust solution. The plant engaged the central reliability function for assistance. Recall that the expert network is comprised of subject matter experts based on their experience and technical assessment data on asset by type and manufacturer. Since this particular machine was a Toyota CNC machine, the centralized reliability function was able to quickly identify subject matter experts to engage in this process. And they were able to easily engage several maintenance technicians with deep knowledge on this kind of CNC machine. The team was brought together for a remote troubleshooting discussion with the plant level team to narrow down the potential issues. The team very quickly had a theory on what the specific problem was based on their past experience and knowledge. Experience and knowledge that did not exist at the particular site in question because they were struggling. So being able to reach out to that subject matter expert network and connect in their experience and knowledge was key to the solution being so fast. Once these technicians were, one of these technicians was then deployed to the site to investigate further, boots on the floor, with support from this expert team remotely. The root cause was found to be a programming issue, and the technician had the issue fixed and the CNC was up and running with good parts within the morning. Recall that this machine had been down for weeks, running poorly for short periods of time, and production rates were severely hampered by the downtime. Within hours, a robust fix was in place. The team also found that the programs for this and other CNC machines in the plant were not being backed up, a significant find that identified potential risks of the same type of failure for all the other CNC machines in this factory. So the team leveraged the root cause to the other machines that could benefit from the same exact fix. This is just one example of how this approach drives fast resolution and prevents future failures through disciplined data collection, organization, and analysis.
For the second part here, we're going to talk about some of the key initiatives that we're seeing happening around manufacturing, some of the things we're seeing. And Jim's going to walk us through a couple more pieces of data from the plant engineering study, and then provide some perspective from what we're seeing out there. So, Jim, if you wouldn't mind walking us through some more of your thoughts.
Yeah, you bet. Thanks, Jeff. This question that everybody sees up here is simply asking the survey group why an outsourcing initiative would be supported in their organizations. I'm sure nobody here is really surprised at the top 2 answers that are on the chart. There really is no question that maintenance and reliability budgets are limited, and that skilled labor shortages have been a real problem in the U.S. for many years. in our experience, the rationale for outsourcing, though, goes well beyond just the scarcity of labor. Of the 100 plus plants that we're supporting today, almost every single customer made some kind of an investment, usually in the form of additional labor, in an attempt to improve performance prior to exploring an outsourced option. What I believe is through this process, they learned how the efficiency and effectiveness of the available labor can really be hindered by things like poor planning, lack of clear KPIs and metrics, ineffective or poorly run storerooms and critical spares availability, work execution management, how work gets done in the maintenance environment is huge. I think most folks that have gone down this path have really realized that the additional resources they put forth just in the labor area were marginalized due to all these other limitations and challenges they've had. We've seen technician utilization losses as high as 30 or 40% simply due to really poor supply chain practices and spare parts. Things like unorganized, incomplete technical libraries, disorganized maintenance work areas, and really poor management of shared tools, those things can make those numbers even higher. What we're finding is that many companies are really doing the right things. Many companies have been going down the path and they've got a solid strategy, they've got good systems, they're adopting new technology, but they still can continue to struggle with that talent side, whether it's acquiring talent, training the talent, or retaining the talent. As a result of this, one of the things we've done is we've worked with customers to let them continue to manage their strategy, continue to really own all of those components, and really lean on us for our capabilities around hiring, training, and retaining that kind of talent. Obviously, we also have a very strong safety culture here. These customers may choose in some cases to retain some maintenance functions in-house and then have us come in as a support function. We call this today our Technical Workforce Solution, or TWS, and it's I think going to be a wave of the future. I think most companies are going to need to find a partner to help them deal with the skilled labor shortage and a lot of these other issues. I'm sure I could talk longer about all this stuff than most people care to listen. So let's go ahead and have a look at the next one. And this next slide shows some of the plans being put in action by the survey respondents to really improve their downtime performance. This chart, as I look at it, it's really encouraging to me. I see a large percentage of the survey respondents are acknowledging that strategy for maintenance is important. Clearly, for the reasons stated earlier, maintenance organizations just may not be able to continue operating the way they have for the last 5+ years. It just changes is paramount. We're all going to have to figure out how to adapt as technology changes and as the market changes. Regarding upgrading equipment, what I would say, probably starting for us and many of our customers around 2017 or 2018, we saw an increased willingness by a lot of companies to invest significant capital into new manufacturing assets, which obviously is fantastic. However, very seldom was downtime or reliability issues one of the top drivers for making the decision about which asset to replace or how those upgrades were done. In most cases, it was tied to the obvious. Capability improvements that maybe enhance some flexibility, capacity improvement that help them with utilization, or just a very clear cost or efficiency gain in their business. I think eliminating old and unreliable assets certainly is a move in the right direction and will be a help. But I do think most plants will still continue to have to battle some of these constrained assets or bad actors. And I would suggest that just in replacing equipment by itself isn't going to be a complete strategy. The topic also around training comes up quite often in our conversations with manufacturing leaders. If you have a high level of turnover in your maintenance team, and some people may argue that training won't deliver results, that you're really just training your folks for their next job at another company. I'll give you my opinion on that here in a minute. We also see that training dollars are really difficult to justify. It's really tough for folks to show a tangible ROI on training. And if you've ever done it, you probably know what I mean. What I've seen as a result of that across many organizations is they revert to what I call kind of the peanut butter approach to training. They spread it all around the organization real evenly and try to make sure everybody gets a little bit, and that's the extent of their training plan. And I think, I'm not faulting people for doing that, but without a real understanding of the very specific gaps that exist among the team, it's really difficult to put all that together. My advice to the group here is when it comes to evaluating training, the place to start is looking at the assets that you have, do an assessment of the equipment and the technology that you have in your plant, and start to think about the types of skills and the capabilities your team is going to need to support that equipment. The second thing would be to really take the time and do a formal skills assessment with your team. We have a tool that we use for that. There's several out there. Our tool happens to be a very standardized and proctored test, so we get very accurate, very thorough results. These two things, I would say, are key to helping us really have and develop an individual training plan for every technician. I fully appreciate that very few maintenance organizations today have in-house training teams complete with all the industrial training curriculum and training assets at their disposal like we do. But this is something you can really lean on a supplier to develop, and we have quite a few of our training resources that our customers are taking advantage of today. So that's my thoughts on the training piece. Regarding the challenge that I talked about earlier, you're really just training people for their next job. I think that's kind of short-sighted. I can tell you that training, at least in the industrial maintenance space, is absolutely a key satisfier, or potentially dissatisfier if you don't do it, but a key satisfier. And our teams really like the fact that we're proactive and they have access to that training. And when done properly, a good, robust training program can absolutely help your retention numbers. Kind of to sum it up in a nutshell, I believe leaders here on the phone and in their respective industries will probably have to do a combination of all the things that are listed here on this chart to really drive results. My advice here is that very few organizations will be able to accomplish all of these things internally by themselves. I think maintenance and reliability leaders need to take an active role in forming some key supplier relationships with companies that can help you accomplish your plans faster and maybe with greater success, certainly, than you could probably do on your own. If you're fortunate and you've got peers who are responsible for sister plants in your organization, a little collaboration can go a long, long way. Leveraging implementation costs for things like training and other initiatives can make the cost more manageable. And also adding scale to some of these things can really help make for a really strong ROI for the business. I'm going to wrap up this section by talking briefly about the maturity of your maintenance organizations and how that may come into play with some of the things that folks are looking to try to drive. So I'm going to go on to the next one, and we'll talk a little bit about that. I'm sure folks here have seen a continuum like this, or maybe the same one at some point. The comment I have here is that if you happen to be responsible for a plant that is in a highly reactive state, you should really focus your improvement efforts on maintenance planning and really good work execution management and PMs, obviously. We have found it's really difficult for a highly reactive team to make the initial transition from reactive to preventive and proactive without some kind of surge or some kind of resource up front to help build momentum and establish that change. In this case, obviously, safety is key. Rallying your people, getting them to understand and get behind the change is key. So in that situation, I don't believe a pure technology play is going to drive the best results. And that's just kind of been our experience. Obviously, you want to do everything, but we all have limited resources that we have to work with. We've also accepted the fact, and obviously, as Jeff said, we've got a lot of plants all over the U.S., Mexico, and UK. Talent in the industry is a very scarce resource. Obviously, the current crisis changes things a bit. Hopefully, this is going to be a quick recovery, but I do believe that's going to continue to be the case. While you may attempt or like the idea of having a whole team of senior technicians and controls engineers who can really come in and fix any problem you might have in the plant, it's just not going to happen. What we've done is we've really tried to use technology in the form of RCMMS. We have what's called a technology hub. We have portals that our folks use to talk about specific technical challenges that we're having across the organization in various plants. We also have an SME, or a subject matter expert network, that we've developed so our folks know who to reach out to when they have a specific problem. While this isn't traditionally thought of as a technology play, it really is. This capability is something our teams use every day. It helps us resolve complex problems for our customers. It really does help avoid delays. I think a lot of plants default to calling an OEM when they get stuck or there's a problem. And today, obviously, with the COVID-19 crisis, that's just not an option. In summary, I guess I'll just kind of suggest here, be realistic with what your current state is. Leverage the heck out of the suppliers and other resources you can get your hands on as you start to build a plan to work along the continuum. At least that is once things kind of start to come back to normal here. So those are my thoughts on the strategy and how that kind of fits. Jeff, I'll turn it back over to you.
Yeah, thanks, Jim, for those insights. Certainly, again, we run the gamut of all these topics running through maintenance and operations within factories, and we look back, for the case of the study here, over the past 5 years again, and one of the critical insights that jumped out at us, relative to the subject at hand, was we looked at the percentage of responders that see maintenance as a cost center, really just to keep the equipment running and to control these costs. And obviously, for those folks that may have a more, some might say, focused or reliability-centered maintenance program, they would see maintenance more as a profit center or a value driver for the organization. So what do you think, the fact that from 2015 we had 55% and in 2020 we're at 59%, what do you think this trend is showing us?
Yeah, it's interesting, and I would say it reflects what we see certainly across the industries that we're supporting today. Now, I think, Jeff, what this also tells me, and I think should probably tell everybody, is most manufacturers still have, I guess, what I would call somewhat of an old school view of the maintenance function. I think it's important that as maintenance and reliability leaders, we really need to start talking and really thinking differently about this business of maintenance. Recently, during a conversation I had with an executive leader from one of our customers' organizations, he offered to me that we, as the maintenance provider in his plant, we don't really deliver maintenance services. And I thought that was kind of interesting. It got my attention. And he said, our efforts are really more about delivering predictable capacity to his operations. Now, I thought about that term, and I thought it really framed up the efforts nicely. I think we've got to be thinking differently and change perceptions in all of our manufacturing organizations about what maintenance is, how it works, and the value it brings to the organization. And it's really not a cost that needs to be minimized, which again is a common thought process, especially at budget time. When you start to look at companies that are considered best in class and are benchmarks when it comes to operating efficiency and capacity utilization and reliability, they really have changed the perspective around how they view the maintenance function entirely. Leading companies are embracing the concept of asset management over maintenance. They are embracing technology and analytics to help them improve the results they're getting. Some companies are even developing what are deemed reliability centers of excellence to help them improve and leverage, enhancements and improvements across the entire organization. Many of them don't even use the term maintenance anymore. So I think that's something we've got to think about in this space and really change the thinking and maybe even change the terminology that we're using to describe what we do. An example of thinking differently about the traditional cost center of maintenance is really the idea of having a skilled technician, maintenance technician, really being responsible for not just the maintenance activities, but also possibly even the operation of the equipment itself. In a typical cost accounting mindset, that would come across as being crazy. It's expensive and labor costs more, and that's not a good option. But I'll tell you, we have done this, and it can really be a game changer. If a highly skilled operator, in this case maybe a maintenance technician that we combine some roles on with an operator, can increase throughput, if they can improve reliability of the asset, the returns can be quite substantial. As we saw in one of the charts earlier, operator error accounts for 11% of unplanned downtime according to the survey respondents. I would say in some situations it could be significantly higher than that. If both the operating performance and reliability can be improved with a move like this, the small increase in labor costs can become relatively insignificant. In several plants today, we're working with our customers to really go beyond simply maintaining the equipment. We're really trying to expand the role of maintenance and getting into looking at things like quality, looking at throughput, all those things that are common if you utilize OEE in your facility as a key metric. It's really created some very different thinking for us and for our customers, and it's created some really good results. So, and Jeff, I'm going to apologize. I know that was a pretty long-winded answer, but those are some thoughts that were in my head as I looked at this trend.
Well, it's a complex subject, Jim. It really is, and I think you're right. We have to look at this through many different facets, and all too often, there's primary objectives and there's several others. And I think, you hit the nail on the head as you kind of walked us through that. And just to summarize, some of the things we just talked about here, relative to some of these key initiatives, again, you got to find a balanced approach. And, as we look at this, and I know there's a lot of reliability engineers on the call today, looking at the industrial automation and state of technology today, and it's both an art and a science, I think. And, we've got to focus on that and understand some of the trends that are going on and take advantage of those. Leveraging supply chain, I think that's important. You talked about the importance of things like training, and a lot of people don't have curriculums and ways to immediately train folks, whether it's safety training or technical training. And then from a supply chain perspective, sometimes your maintenance group is only as good as the industrial parts at hand. So making sure you got connectivity to both your maintenance organization and the industrial parts strategy as well. And then last, but certainly not least, is getting cost out. And, when we talk to lots of manufacturing customers, and I've done lots of customer focus interviews through the years, and, it's really two facets of this. Firstly, you've got to have transparency into the data and see exactly what the true cost is. And then once you understand that true cost of maintenance, or as we call it, the cost buildup, you've got to take everything into consideration. And it's some of the training that we talked about here. It's the PPE that folks have to use every single day, uniforms, tools, etc. So really uncovering that true cost of maintenance is critical in getting some of that cost out. And we're going to our final topic here with an eye on the clock. We're going to talk about some of these implications. So we've talked a lot about some of the challenges and the opportunities that are in front of us here. And we're going to take a couple of minutes. We're going to talk about some of the implications for maintenance and reliability services. And we're going to kind of frame out our responses here around kind of the advanced manufacturing and technology areas. And once again, Jim's going to talk about a couple of the survey results that came in, relative to this topic here, and give you some more thoughts around those topics, and then we're going to wrap up. So, Jim, maybe you can talk about the first piece of data here again.
Yeah, you bet. Thanks, Jeff. Yeah, the thing that kind of jumps off the page at me is I'm surprised that safety didn't really make this list. It is certainly an area where we have applied some of the technology to help make our folks safer and make working on the equipment safer. But that said, one really interesting example of that we have firsthand experience with around this, all the new technology in IoT is we had a current customer of ours who approached us as they were looking to build a new kind of manufacturing plant. Their vision was, I think, kind of that ideal high-tech vision of having a plant that didn't require any machine operators. So we sat down and collaborated with them, and we really went through a process to redefine the functions of the normal operator function, the setup functions and maintenance functions, and those kind of things. And what we have today is we have a plant where, our team, which is traditionally thought of as a maintenance team, we are operating, tending the equipment, we're making sure material is flowing, we're making sure AGVs are carrying material through the plant. If they have to stop and get reset, our folks do that, but we're also keeping an eye on quality. And their engineers are really not operating, but running and managing the plant from a central control room. It's really an impressive setup. And I would just say technology it's so impressive what's available in the market today. And I'm just going to go ahead and transition to the next slide and kind of look and see how respondents say they're going to manage maintenance in the plants today. But certainly a great time, and we've got access to more technology than we've ever had. I don't know about the folks on the call, but these results to me are really pretty surprising. I think of the old adage of if you can't measure it, you can't improve it, and maintenance data obviously is very crucial. It's shocking that 50% of respondents are using a CMMS to manage their maintenance, and also 46% are still relying on paper records. I can tell you from our perspective, there is no way we could operate our business and deliver the results that we do to our customers without good systems and real-time analytics. Obviously, we've got great people, but those are critical aspects. There's really no way if you're running or responsible for a maintenance organization today that you can drive improvements without some of these key metrics and systems. I don't think this slide needs much more discussion, so I'm going to go ahead and move on to the next one. This slide talks about advanced technologies and capturing of machine data and what folks are seeing out there. When I look at this kind of information, I'm reminded of a quote that I've read that has really stuck with me for a long time. And this gentleman, I'll give you his title. His title is Enterprise Infrastructure Architect and IoT Lead. So he's smack in the middle of all this technology initiative that's going on. And this is what he said about it. He said, "The advice I'd give any organization is first and foremost, understand the problem. Fall in love with the problem and not the solution." He goes on to say, once you understand the problem, look to partner with somebody who can bring future-rich, not feature-rich, solutions. This gentleman happens to be with Rolls-Royce. It's a quote I think that's very appropriate in this technology space, and I'm sure there's a lot of other perspectives and opinions on that. So I'll wrap it up with that, Jeff.
Hey, thanks, Jim. And it's hard to encapsulate everything that's happening, across the technology spectrum in manufacturing here in just a few minutes. But I think those are some certainly words of wisdom there, and I appreciate the quote that you provided there from the gentleman at Rolls-Royce. I think that rings true for a lot of people out there today. As we wrap up this final section here, just a critical insight that jumped out again here. Again, looking at maintenance services that are outsourced. And the ones that take advantage of these new technologies, again, we see a bit of a trend here. Over the past 5 years, we've seen that go up a few points. Jim, do you expect this trend to continue?
Yeah, Jeff, absolutely. We see it for all the challenges and the issues that we've talked about already, and obviously the study has a lot more meat on the bone here than what we've covered today. But I do believe whether it's a wholly turnkey outsourced solution, or if it's just partnering with somebody on certain aspects of your maintenance strategy, I absolutely see that's gonna continue.
Thanks, Jim. I think you're correct on that. And as we wrap up this section here, I think again finding a balanced approach to these maintenance implementations are key. And when you look at the topic of this webinar, and it's really the cross section between the human workforce component and the technology component, these are just key areas that I think are going to be table stakes for everybody moving forward. Advancing the skills of the workers is key. Redefining roles, and Jim, you had said maybe 10 or 15 minutes ago, the way roles are defined and the way that maintenance teams are structured today and in the past few years are going to change, and it's probably going to change for pretty dramatically. And then, of course, embracing the technology once you identify that and the cost structures that surround it. So thank you very much for your input.
Thanks for a very comprehensive presentation. We look forward to seeing you in the live Q&A session immediately following. Be sure and have your questions ready. Thanks for joining us, and we hope the information provided will suit your purposes.